Okay, we're going to look at soils now. And soils are important because they provide this organic component and inorganic component of the ecosystem that promotes plant growth. And there's a huge variety of soils, and there's different ways to determine the type of soil, and we'll look at that. Make sure you watch those videos, and they will give you a little bit more detail and show you how scientists go out into the field and study soils. It's kind of a fascinating subject to get into. Now, soil is the mixture of weathered rock particles and organic material mixed with water and air. And the organic matter in soil, it's all the living microorganisms, plant roots, dead, partially decomposed plant and animal matter, and matter that's fully decomposed, which we call humus. Now, it too is an open system. It has an input, which is all this, and an output, which is what the plants will absorb. And importantly, too, human activities can dramatically affect soil development. So this is just a kind of a cross section again from your book, and you can see how this works, where it's this whole system here with plant roots, that have bacteria that fix the nitrogen, that move the water around. You have plant litter that decomposes and adds to the soil. You have worms, you have mammals, you have insects, you have fungi, and all this works together to recycle or to cycle nutrients. Now, the weathering of rocks provides the raw material. We talked about that a few chapters ago as chemical weathering, biological weathering. It will break down the rock. That provides the raw material for the soil. And the parent material determines the resulting soil type. And then climate is a major influence, because you can have wet, dry, warm, cold, and the biological activity also plays a role. And then this all happens over time, and then it's influenced, of course, by the topography and the slope of the region. So thicker soils develop on plateaus and valleys and in valleys. Soils on north-facing slopes hold more moisture. So you have thinner soils on steep slopes and drier soils on south-facing slopes. So slope orientation is very important. So over here, you get shallow slope, lowland valley. So you have rich soil here because all of this is running off slopes down into the valley. So it's a little patchy, poor mountain soil, and better accumulated material down here that provides a richer environment. Also up here where it's flat, higher elevation, it's still going to be thicker soil because the water isn't carrying it down slope to the valley. Now, soil building can take up to 500 years to create just a few centimeters, and farming practices are very important because you don't want to lose soil faster than it can form. But in today's earth, we have numerous problems facing the creation of soil. One of this is desertification, where we have sand, especially from desert areas like the Sahara, moving in, covering up soils in sub-Saharan Africa. Overgrazing, you remove the plant life, that affects the soil. Deforestation, you remove the trees, that affects soil. And salinization, where as water, if you warm up the temperature of the atmosphere, water will move up, evaporate, but it leaves minerals and salts behind, and that can destabilize soil as well. So you want sustainable agriculture. And one of the ways to do this, you plow on contours, because that reduces it. You just don't plow as much. And I did videos in the module shows plowing on this. Again, so you can see here, this is the soil here. Down to there's a human for reference point. That's the soil. And notice it's different layers, if you will, which we'll get into in a second. We'll call those soil profiles. Okay, so No-till farming, you get better, more moisture retention and looser soil, and it's great for wheat. Conventional farming, so you get tractors that till or plow the soil to break it up, and that's for shorter and root systems, a little longer, so it goes further deep the soil. This is better for strawberries, for example. So, as I said, one of the things that can dramatically affect soil development is what we call desertification, the removal or the covering of arable land and good soil or usable soil by sand. And this is a problem as you remove land cover, especially here for fuel and for structures, allows the desert to encroach upon the arable land. It's a big problem in India, out here in Sahel, that's part of sub-Saharan Africa. Also here in even in the Western United States. And this is all human, mostly human induced. So that's one reason that we want to try and stop it, because if we can improve agricultural techniques, we can halt desertification, and that will improve soil quality and soil development all over the world. Okay, now I'm going to stop here, and then we'll do soil horizons. Now, again, there's a video in the weekly module that discusses soil horizons and goes into a little bit more detail. So try and watch that, okay?